So let's see the implementation of constructors. So I will just use the default one. Then I will have, okay, before writing int main, I have to define a class. Let the class be student. In this I will write some private int x. Okay, we'll take one again. Let's take a simple one. Then we'll make it slowly complex. In public, maybe I will take another variable int y. Okay, we can have it like this, int x and int y, or also maybe no, we'll simple first execute the simple ones. So I have student. See, I am writing a default constructor here. What is the name of the class? Student. So I am writing a default constructor. Okay, and in that I am writing one message, cout default executed, right? Anyhow, we use that to assign some value to this, but we will do that using parameterized constructor. Let us write this and say x equal to 0. So assigning or maybe I'll take 5. Okay, so this is about the default constructor, and we are done with the class definition. So from int main, see what I have taken a private variable, and I have defined a default constructor. I have defined a default constructor. The class name will be the constructor name, right? In that I have written some set of statements, and I have written that as a public function. So int main, as soon as I create an object for this student, this constructor will be executed. Student s1, if I do, that's it, and write return 0. Okay, so we have created a student s1 and object s1. So what happens? What will be the expected output of this? As soon as you do s1, anyhow we are not printing the value of s. Maybe I'll add one more function, display, void display. So I want to display the value of x. The value of x is, sorry, x and L, right? So I will, after that I will write s1 dot display function. I will call this. Okay, so what's happening here? See, in main I am creating an object s1 for the student class. As soon as I write this statement, immediately the default constructor is executed. Then I am writing s1 dot display. This function is executed, but I am using the value of x, which is a private, so it is assigned using the help of a default constructor. Let's run this and see any mistakes. No. See here, see the output, default constructor is executed, the value of x is 5, right? So in the same program I will try to add now, this is, I think you understood how the default constructor is working. Okay, it is assigning x value to 5, and that I am able to see using display function. Sorry, in the display function I am able to see the value of x. Now let's write a destructor. Here itself, let's write a destructor. Okay, so how to write the destructor of a class? You have to use the tilde operator and the class name. Sorry, tilde operator and the class name, open flower bracket, right there, cout destructor executed. Okay, this I can write it, and L. So what should be the sequence now? What is the expectation here? See, when I write int main student s1, so as soon as I write this line is executed, the default constructor gets executed. So it says default constructor executed and assigns x to 5. Then I am writing s1 dot display. So it says the value of x is some whatever we have assigned. Okay, then after that nothing else there. But after these two blocks are completed, before coming out of the program, it will execute this what we say destructor. It will execute this destructor. It will say destructor block executed. Okay, okay, this is fine. Let's execute this and see. See here, default constructor executed, the value of x is 5, and the destructor is executed, right? So you can see the order here, default constructor executed, value of x is 5 and the destructor is executed. Okay, so this way we have implemented only the default constructor and we are seeing the output. Okay, we are seeing the output. I hope it is clear. We have also studied that constructors can be overloaded. How? I can pass the arguments to the constructors. We can pass the arguments to the constructors. So in the same program, without changing anything, I will add a parameterized constructor also. Okay, let's add a parameterized constructor in the same program. Okay, so I will write under this default constructor, I will write another parameterized constructor. So product, class name is product, right? Yes, product. This time I am passing some arguments. Let that be int x. Oh, x already used. Let that be int a and int b. Let that be int a and int b. Open bracket. I will write that x equal to a plus b. Okay, whatever value I am receiving from that parameterized constructor, I am updating that value of x using these values a and b which are passed through the arguments. Now I will write cout the parameterized constructor. Parameterized constructor executed. Okay, I can write the parameterized constructor executed. See what I have done here. This is again class name. Class name means it's a constructor. I am passing two arguments, right? So here when you write product P1, we are not passing any arguments. In that case, what will happen? This default constructor will execute. This block will execute. Okay, but when I give, let me again write product some P2 with some values 10, 20. Now I will write P2 dot display. Let's feel the difference now. See, when I write when I create an object without any parameters, this corresponding default constructor will be executed. When I create an object with two parameters, then this corresponding constructor will be executed. Okay, so this is matching. I am passing 10 and 20 as the values, and this int a and int b is matching, right? So let us see whether this sum 30 is updated here or not. Okay, I want to display the value of x, that is again anyhow it's there, right? So let's execute this and see whether the parameterized constructor is working or not along with the default constructor. Oh, something wrong. Oh, sorry, it should be P2, right? Object P2. Yes, see here, see the output of the program. First one, the default constructor executed. When I create an object here, if you see the main program here, in this main program, I created object P1 without any arguments. So the default constructor executed. Then the value of x is 5. Then you see the parameterized constructor is executed. The value of x is 30 this time. How it became 30? Because I am passing here 10 and 20 as the parameters. So it is adding. And you see 2 times the block is executed. The destructor block executed, the destructor block executed. Why? Because I created 2 objects. Since we have created 2 objects, right? Since I have created 2 objects, 2 times the destructor block is executed. So this is the demonstration of parameterized constructor. Okay. So we will implement copy constructor, but we will implement, there are 2 ways of doing it. One way, we will not write any logic for that. Compiler will automatically do that. Let's see. See, I have an object P2 here. I have an object P2 here. Okay. I want to create another object P3. Product P3. Okay. What values I want to pass here? I want to copy the values of P2 into P3. I want to copy the values of P2 object into P3. And then I'll write P3 dot display. See what I am doing here. You forget about the default constructor now. You forget about default constructor. There is a parameterized constructor. I am creating an object P2. I am creating an object P2 with values 10 and 20. It means P2 dot A contains 10, P2 dot B contains 20. Now, when I am displaying the value, it is giving me an answer as 30 because the logic here is to write x equal to A plus B. See, I have created another object P3 for this class product. Instead of giving the parameters, I am passing object as input. So this is the implementation of copy constructor. By taking using implicit copy constructor logic. Okay, right? What we are doing here, we are not writing specifically any program for implementing copy, but you can see when you see the p3 dot display output, you will come to know whether the copy constructor is working or not. See, above in the class I have not written anything there. I have not implemented any logic for copy constructor, but we are trying to take the advantage of the compiler doing it implicitly. Okay, so let me execute this and see whether it is copying. See here, it is nicely copying. The default constructor executed, the parameter is constructor executed, and 30. See, the value of x is 30. Value of x is 30. How this statement came? If you want to differentiate, maybe you can write it here. See out the copy constructor executed. Right? The copy constructor executed, and then you can see the output. Let me run it once again. See, the default constructor executed, x is 5. The parameter is constructor executed, x is 30. The copy constructor executed, x is 30. Why it is 30 again? Because I am copying the content of object P2 into object P1. And 3 times there is this statement, the destructor block executed. Why 3 times? Because we have created 3 objects of the class. We have created 3 objects of the class. Now let us go for the next version of copy constructor, where we manually or explicitly write the logic for implementing copy constructor. So I'll just comment this. So yeah, like we have written default constructor, parameters constructor, we will write logic for copy constructor also. What is the logic for that? Class name, again class name, ampersand some object t. Okay, some object t. What I have to do here? What is the variable here? We have only one variable x. Right? So I can write x equal to, can I say a equal to, can I declare a? No, because a is known only to this variable. No, a is known only to these values. This t does not know them. Right? So I will write here x equal to t dot a plus t dot b, or let us maybe we can use multiply symbol here. Right? I am writing some operation there. Then see out copy constructor executed. Is it a valid program? See, I am passing an object here t. It means when I am passing P2 here, the P2 object is copied into this. What does P2 holds? P2 holds x value, that is 30. So I think this will throw error. It will say a and b. Yes, I know. A and b are not known to this. So you cannot do this. You can only write t dot x. Okay, t dot x. What is this x? This x is the this value. Let's execute this. Now you can see the copy constructor is working. The default constructor, parameters constructor, the copy constructor. Why? So this is the explicit logic. Okay, I will write it explicit copy constructor executed. Okay, so whatever is the private member, that only can be assigned to this x using this t. So if you see here, see the explicit copy constructor executed. Okay, so this is the logic of implementing constructors and destructors. Okay, so we have to see how to use initializer list to do the same job which the constructor was doing it. Okay, let's see the implementation of initializing the private variables of a class using initializer list. Okay, it is not that it does not use this constructor, but it is another way of creating the assigning values to that private data members. Right? So I will take a class. Let me take class student, and I have some private, like see C++ is also a case sensitive language. You have to be careful when you are writing those no keywords. So I'll write some int a comma int b. Okay, I have declared two variables now, public. I will implement the I want to implement the initializer list. So I'll use the class name, right, as function. Here I will write int x comma int y. See what is the syntax of initializer list? You have to pass the arguments here and then write colon, then this private variable a of x comma b of y, like this you have to write a of x comma b of y, and then you can write open and close brackets. Empty, you can also give empty open and close brackets, right? So this is the member list. This is the member list. If you are having 10 private variables, you keep writing here int x, int y, a of x, b of y, and so on. So indirectly I am implementing a parameterized constructor. I am implementing a parameterized constructor here, right? So I will also implement the display function. So I will write void display, because I want to see whether the values of a and b are copied or not. The cout, the values of a and b are, what you can write here, you have to write x and some space, and then I want to give b. Sorry, is it x? No, it is a b, right? The private variables are a and b and l. Okay, so this is about the display function. I am closing it. I'll just quickly create an object int main. I'll write the default statement return 0. See, now what will happen? I have to create an object. I have to create an object with two values. Okay, this is just an alternative for constructor, parameterized constructor. But we have studied that there are some situations, there are some conditions where the constructor cannot work. One among them is the non-static constant data member, the reference variable, the pointer variable, and in the inheritance concept, base class, child class, all those places we cannot use constructor to initialize the default values for the private members. So we are going for the concept of initializer list. Okay, so let me create an object for this class student s1 of some values 10 comma 15. Okay, so let's see whether this 10 comma 15 are assigned to these variables a and b. How will I know that? I will know that with the help of a display function. So s1 dot display. Okay, so I am creating an object s1 and I am passing some values to that object. So when you write this statement, the parameterized constructor should execute, but we are assigning values using the logic of initializer list. Why? What is the logic of initializer list? How we have to do it? What is the syntax for that? See, class name, argument list, close it, colon, give colon there, then the private variable of the temporary local variable, comma, like this, private variable 1, comma, local variable 1, comma, separated values, private variable 2 of local variable 2. Unlimited list you can keep including here depending on the variables declared in the class, and then just write open and close if you don't want to do anything. If you want to write something, you can write it here, it will execute. See, we will write one more statement. First we will execute this and see whether it is working fine or not. Then I will write one statement and show you how the initializer list is working. Okay, so I have created an object, I am passing the values and I am displaying the values. Let me execute this. Student does not have any field name b. Private int a, int b. Oh, sorry, this is int a comma b, right? Yeah, small mistake. Yeah, now see, the values of a and b are 10 and 15. The values of a and b are 10, 15. It means the initializer logic is working. So to validate that our argument, let's write here, cout the initializer list is working, right? So let's see whether this message appears or not. See, the initializer list is working. Values of A and B are 10, 15. Okay. So this is one way of implementing the initializer list. This is an alternative for constructors. Okay. It is an alternative for constructors. We are writing this. See, can I write? I'll write one more block here. Let's see the difference. I will write a parameterized constructor directly here. Okay. I'll write the parameterized constructor directly here. Int x comma y of flower brackets. I'll write here, what is that? A equal to x, B is equal to y, and C out the parameterized, let me copy this from here. The parameters constructor executed. Students, please see here. See, I am using initializer list to assign values to the private data members. I can do this using method 1 and also this way. Okay, any one of them is okay. You can write it like this. You can give here int x, int y, a of x comma b of y. It does the job, same thing what this is doing. So this is the parameterized constructor implementation. This is the same thing using initializer list. Okay, so these are the two differences, and there is a display function. Okay, but can I write two things like this? What will happen if you do? See, it is saying cannot be overloaded. Why? There are two functions with same function name. We studied function overloading. When you have same function name, then the argument should differ either in the number of arguments or in the data type of the arguments. Right? If you remember, when we do function overloading in C++, you can give the same function name with multiple variables. Right? The variables should differ either in the data type or in the number of variables. So this is not allowed. So we will just comment this. So this is the, oh sorry, */ no, I'm missing something. Right? So we can now see whether it's executing. Yeah. See, the initializer list is working. The values of A and B are 10, 15. So like this, we can implement the initializer list also. So we have seen the implementation of 3 different constructors, and also same thing done using the initializer list.